You sit at your desk, staring at a task that you logically know you need to complete. The consequences of avoiding it are clear, the benefits of finishing it are obvious, and the deadline is rapidly approaching. Yet, when you attempt to mobilize your energy to begin, you encounter an invisible, immovable internal wall. Your body feels physically heavy, your mind feels entirely hollow, and the simple act of starting feels as exhausting as running a marathon. Pop psychology frequently mislabels this state of profound paralysis as simple laziness, a lack of ambition, or a failure of personal discipline, telling you to download productivity applications or force yourself through sheer willpower. But these surface-level instructions fail entirely because they treat a deep metabolic shutdown as a minor personality defect. The crushing inability to generate focus and drive is not a moral failing or a permanent lapse in structural willpower. It is the direct consequence of an ancient, automated biological mechanism. Your nervous system has intentionally entered a state of strategic non-compliance, systematically cutting off your internal power supply to protect your brain from what it perceives as an unsustainable energy deficit. To understand why your drive has vanished, we must look past self-help cliches and isolate the literal neurobiology of motivation. To map the exact architecture of this motivational paralysis, we must first dismantle the deep scientific misconceptions surrounding the brain's primary currency for drive, dopamine. For decades, the public has been told that dopamine is the chemical of pleasure, a reward molecule that floods your system only after you achieve a victory or experience enjoyment. But neuroscience reveals a completely different reality. Dopamine is not the molecule of satisfaction. It is the molecule of pursuit, anticipation, and visual focus. It is the raw neurochemical fuel that commands your brain to look outside itself, assign a value of high importance to a future objective, and generate the physical friction required to move toward it. When your baseline dopamine signaling is healthy and robust, the tasks before you possess an implicit sense of urgency and texture, making action feel natural and fluid. But when your underlying neural circuitry experiences chronic stress, continuous digital overstimulation, or prolonged cognitive friction, this delicate chemical pipeline breaks down entirely. The lack of drive you experience is the physical manifestation of a starved mesolimbic pathway, where the chemical signal to care has been systematically muted at a cellular level. The primary neurological gateway that governs this motivational sorting process is a highly specialized structure known as the nucleus accumbens. Tucked deep within the subcortical regions of the brain, the nucleus accumbens acts as the master interface between your emotional desires and your physical movements. It is the precise junction where your abstract thoughts about a goal are translated into the literal muscular action required to achieve it. Under ordinary circumstances, when a meaningful target is identified, the nucleus accumbens registers a precise surge of dopamine, which instantly overrides your baseline physical inertia and pushes you into motion. However, this structure operates on a strict, unyielding regulatory mechanism known as receptor homeostasis. When your nervous system is exposed to a continuous, modern bombardment of hyperstimulating inputs, constant multitasking, and low-grade survival anxiety, the nucleus accumbens experiences chronic chemical saturation. To protect your delicate neural networks from permanent neurotoxic overload, the postsynaptic neurons react defensively by physically retracting their own dopamine receptors back into the cell walls, effectively closing the gates to further stimulation. Once this cellular downregulation occurs, your brain enters a profound threshold crisis that directly paralyzes your daily productivity. Because a vast percentage of your dopamine receptors have been physically pulled back into the cell walls, the baseline level of neurochemical signaling required to trigger an active emotional response changes drastically. The everyday tasks that used to carry enough chemical weight to cross your motivational threshold, such as reading a book, writing a script, or organizing your environment, no longer possess the structural capacity to register a signal inside your blinded nucleus accumbens. The threshold for action has been raised so high that normal reality fails to cross it entirely. If a task does not promise an explosive, instantaneous, and unnatural hit of stimulation, your ancient survival circuits simply categorize it as irrelevant, leaving you feeling completely detached, immobilized, and numb. You find yourself trapped in a state of passive stagnation because the biological machinery required to translate your rational goals into physical drive has been locked behind a wall of cellular defense. While receptor downregulation blinds your motivation centers from the outside, your hyperactive survival circuits simultaneously trigger a secondary chemical lockdown from deep within your brainstem. Under conditions of prolonged mental exhaustion or chronic lifestyle overload, the brain begins to synthesize and release a highly potent peptide known as dynorphin. Dynorphin serves as the dark evolutionary mirror to endorphins, acting as a powerful biological brake on your entire reward pathway. It binds directly to specialized kappa-opioid receptors located inside the ventral tegmental area and the nucleus accumbens. When dynorphin locks into these structures, it aggressively suppresses any further release of dopamine across your synapses, introducing a deep, systemic feeling of profound dissatisfaction, fatigue, and physical lethargy. This chemical shadow is not a malfunction or a disease. Evolution explicitly designed dynorphin to act as an automated behavioral off-switch, intentionally making an animal feel completely hollow and exhausted to force it to retreat from its environment and conserve its vital metabolic resources. This internal chemical shutdown is heavily reinforced by a profound metabolic disconnect inside your highest cognitive network, the prefrontal cortex. The prefrontal cortex is responsible for your abstract future planning, long-term reasoning, and the complex integration of your goals. To maintain your drive, the prefrontal cortex must maintain a highly fluid, continuous dialogue with your deeper emotional reward centers, allowing you to project a sense of hope into the future and endure current hardships for a long-term reward. However, during a state of chronic motivational burnout, the continuous release of stress hormones like cortisol alters the functional connectivity between these vital regions. The neural pathways that allow the prefrontal cortex to draw emotional energy from the rest of the brain become highly constricted, leaving you trapped entirely inside your analytical mind. You can think about your goals, you can calculate your deadlines, and you can plan your next steps with high logic, but your thoughts are completely severed from any underlying emotional warmth or physical urgency, turning you into a paralyzed observer of your own stagnation. To fully comprehend the depth of this motivational paralysis, we must look past superficial dopamine metrics and analyze the strict boundaries of the brain's metabolic budget. Your brain is an organ bound by an unyielding law of resource allocation. While it accounts for a mere 2% of your total body mass, it consumes more than 20% of your body's entire daily energy supply, relying completely on a continuous, uninterrupted stream of glucose and oxygen. Every single calculation, task switch, and emotional regulation requires a measurable expenditure of cellular energy at the mitochondrial level. When you force your nervous system to operate at maximum capacity for months or years on end, managing constant modern stresses, micro-decisions, and continuous sensory inputs, the prefrontal cortex depletes its available energy reserves. The brain eventually reaches a critical point of systemic deficit where it can no longer afford to run its highest, most expensive circuits. Emotional processing, deep anticipation, and intense focus require an immense amount of cellular energy to produce. To protect its basic survival functions, the brain systematically cuts funding to these luxury motivational networks, choosing to freeze you in place rather than risk complete cellular collapse. This severe restriction of your energetic budget directly triggers a phenomenon known as cognitive fatigue, which completely alters your perception of physical effort. Deep within the anterior cingulate cortex sits the neural machinery responsible for calculating the cost-benefit ratio of every single action you take. In a healthy, fully charged nervous system, this region analyzes a task and determines that the energetic cost of starting is well worth the potential future reward, sending a green light to your motor networks. But when your brain is operating in a metabolic deficit, the anterior cingulate cortex violently distorts this calculation. It magnifies the perceived effort of a simple task by orders of magnitude, making the act of opening a document feel as physically demanding as climbing a mountain. Concurrently, it reduces your perception of the upcoming reward to absolute zero. Your brain is not miscalculating reality by accident. It is intentionally rigging the internal math to ensure that you refuse to exert energy, effectively forcing you into a state of behavioral rest, so your mitochondria can rebuild their depleted resources. While your metabolic centers are enforcing this behavioral freeze, a profound structural shift occurs in your brain's ability to accurately perceive the concept of time. Because the prefrontal cortex is starved of healthy dopamine signaling, your neural networks temporarily lose their capacity to run accurate simulations of the future. When your motivation pathways are functioning normally, you can easily look ahead and imagine the deep satisfaction, relief, or success that will come from finishing a project, which provides the precise emotional fuel needed to endure current friction. But when chronic burnout deactivates these predictive networks, your mind loses its forward-looking lens completely. You look into tomorrow, and your brain can only project the exact same flat, exhausting, and paralyzed blankness that you are experiencing in the present moment. This creates a powerful, terrifying cognitive illusion of permanence. You begin to believe that this state of profound motivational exhaustion is your new permanent identity, failing to realize that your capacity for drive has simply been placed into a temporary biological standby mode. This state of deep internal paralysis is no longer an isolated anomaly. It has become a widespread systemic phenomenon of the modern hyper-to-connected era. Millions of individuals move through their daily routines under a heavy veil of chronic exhaustion, experiencing the exact same profound executive dysfunction without ever understanding the underlying biological cause. Because pop culture continually frames productivity as a moral choice, a product of positive thinking, or a reflection of hustle, people suffer in absolute silence, carrying an unnecessary burden of intense personal guilt and shame. They assume they are uniquely broken or inherently lazy, failing to realize that their symptoms are the predictable, mechanical outcome of an ancient biological processing system being forced to run an overwhelming, unnatural volume of modern data. When you analyze the phenomenon through a clinical lens, the mystery vanishes completely. The widespread rise of motivational burnout is not a character flaw of a generation. It is the direct consequence of a deep evolutionary mismatch between human biology and the modern world. The core tragedy of modern motivational burnout lies in this severe evolutionary mismatch between our ancient biological wiring and modern lifestyle architecture. The human motivation system was perfectly engineered by evolution to handle immediate, physical, and short-lived pursuits, such as hunting for food, securing shelter, or fleeing from danger. These primitive actions offered an immediate, concrete loop. You exerted energy, you achieved the physical reward, and your brain returned to a baseline of deep parasympathetic rest. Today, our primary tasks are entirely abstract, invisible, and deferred, such as studying for a degree, building a digital business, or managing long-term financial systems. Your ancient survival circuits do not know how to process a task that requires months of invisible effort before delivering a reward. They treat an abstract, long-form modern project as a massive waste of precious metabolic resources, actively shutting down your internal drive to prevent you from wasting energy on a pursuit that doesn't yield an immediate physical survival benefit. Ultimately, The agonizing weight of chronic procrastination and exhausted motivation must be reframed, not as a psychological failure, but as a mechanical certainty. Your brain is an ancient organic survival machine performing a highly precise automated calculation using completely distorted modern inputs. The intense internal resistance you feel when attempting to work, the mental fatigue, and the absolute lack of drive are definitive proof that your nucleus accumbens, your anterior cingulate cortex, and your default mode networks are fully operational, working exactly as evolution intended to shield you from absolute metabolic bankruptcy. By stripping away the layer of personal frustration and analyzing this intense daily friction through the cold clarity of neurobiology, the structural reality of the human mind becomes entirely clear. Your brain is not broken or permanently damaged. It is simply overprotecting its energy reserves in a world it was never evolved to fully understand. This concludes our deep diagnostic investigation into the physical anatomy of exhausted motivation.